All right, this is the section of greatest common factoring. You're going to find the greatest common factor and factor by grouping. We have three objectives. Find the greatest common factor is the first one. Factor out the greatest common factor of a polynomial is the second one. And then the last is factor by grouping. And you can see this first section is called factor. It's really finding the greatest common factor, which is also known as GCF. And you got a couple of steps. You have find the largest number that can divide into all the coefficients. The coefficients are the numbers in front of the variables. Then the second step is find the variables that are the same in all terms. If you put them together, you make a monomial. That's the greatest common factor. So let's look at a couple of problems here. Slide this up. Got example 1. And again, this should say not just factor, this should say find the greatest common factor. That's really what we're doing here. Factoring will come up in the next problem. So the greatest common factor, we want to find the largest number that goes into both 6 and 10. So we got greatest common factor. Largest number that goes into both 6 and 10 is 2. So that's the coefficient on our greatest common factor is 2. Then we want to find all the variables are the same. Well, when you mean the same, that's talking about powers too. They have to have the same power, which means we have a couple of x's here. Let me put those in red here. We got an x squared and we got an x cubed. The variables are the same. They're both x, but they have different powers. So how we get the greatest common factor is it is the one with the lowest power. That's the greatest common factor. So it would be x squared. So our greatest common factor is 2x squared. Let's make that a little better. Squared. 2x squared. That's A. For B, we're finding the greatest common factor again. But now we have three terms. And we're looking at the coefficients, the numbers in front. We've got 15, negative 9, and 12. 15, negative 9, and 12. The negative doesn't make a difference. It's going to be, because two of them are positive and one of them is negative, it's going to be a positive number. That's the greatest common factor. The biggest number that can go into all three of those is 3. So we've got a 3. And then we're looking at our variables. We're now looking at the y's. You've got a y cubed, a y to the 4th, and another y cubed. They all have a y, so y is definitely a factor. The power on the y has got to be the lowest power. So we're going to have y cubed. Yeah, let's make it black. Y cubed. So the greatest common factor for B is 3y cubed. Now let's look at C. There's no coefficients. There's no numbers in front. None there. We don't have to worry about them. If we're going to find the greatest common factor of these, we're just working with the variables. They both have an x and a y. So x and y is definitely part of it. The power on each of them, again, is the lowest power that each has. The x's have a 5th power and a 4th power, so the lowest power is x to the 4th. The y's have a 3rd power and a 4th power, so the lowest power there is y to the 4th. So what I want you to do now is stop right here, pause, and then go ahead and do the checkpoint 1, right down here, checkpoint 1, A and B. After you come back from pausing, I will give you the answers to those. All right. The answer for A, the greatest common factor on A is 3x squared. And the greatest common factor on B is x squared y. That's your answers for A and B. So we're going to move on. We have now, we're going to be doing the factoring out the greatest common factor. This is actually factoring. And factoring, let me adjust this here. We're going to have a little definition up here, because it's not in this paper and it should be. Factoring, and you should write this down, is finding what to multiply to get an expression. Finding what to multiply to get, and run out of room, an expression. A little easier for you to fit it in with a regular pen. It's a little hard with my stylus. All right, so to factor something, you're still going to use the greatest common factor. We're going to find out on A here what the greatest common factor is. And then we're going to take that greatest common factor and we're going to divide it into each of the terms in the expression. So if we look at, we have an x squared here, we have an x squared right there, but there's no x on the 30. So x can't be a factor because it's not in both of them. But we do have the numbers 5 and 30. The biggest number that goes into 5 and 30 is 5. So our greatest common factor is just 5. Put that in black. Greatest common factor is just 5. And what we're going to do with that greatest common factor, we're actually just going to take and divide each one by 5. And what we get when we divide each one by 5 is just x squared plus 6. Now, we all know that x squared plus 6, let me write this down right, x squared plus 6 is not equal to 5x squared plus 30. There's no way it can be. So there's something missing. What do we do with the 5 that we divided by? Well, that greatest common factor, that 5, it goes out front. You put what's left after you factor in parentheses, and you put the greatest common factor out front, you put it as a 5. Now, how do I know that's equal to it? We can do a check. If I want to do a check here, you just distribute it back. You take 5 times x squared. That's 5x squared. And then you take 5 times 6. That's 30. And we can see it checks with our original problem, which is 5x squared plus 30. So we know that it worked. So again, factoring is finding out what we multiply by in order to get an expression. And if we take 5 and we multiply by x squared plus 6, we're going to get 5x squared plus 30. Let's try B. The greatest common factor is between 18x cubed plus 27x squared. We now have an x in there, and the coefficients 18 and 27. Those are, the biggest number that goes into both of those is 9. 9 goes into 18, 9 goes into 27. The x's, we do just like we did when we were finding our greatest common factor. There is an x in there. The power is the lowest power. It's going to be squared. So we're going to take 9x squared and we're going to divide it into each 9x squared, and we're going to divide it into each of these terms in this expression. If I take 9 into 18, I get 2. And x squared into x cubed. What you do is technically you subtract the powers. You can think of it as canceling out. I can cancel out the 2 powers that are on the bottom, the squared on the bottom, with 2 of the 3 that are on the top. And if I do that, I'm left with just an x. So 3 minus 2 is 1. That would be the power on the x. And we've got also a plus here. So the plus is going to stay on. That could change with a negative, by the way. It may or may not, depending on what your greatest common factor is. But for now, if we're taking a positive number 27 and dividing by a positive number 9, it's going to stay positive. So 27 divided by 9 is a plus 3. And then we've got x squared on top, and we've got an x squared on bottom. You can think of subtracting the 2 2's. That is 2 minus 2 is 0, so that'd be x to the 0, which cancels out. X to the 0 is just 1. Or you can think of x squared divided by x squared cancels out, and it goes away. So we've got 2x plus 3. That means our greatest common factor still has to go out front. 9x squared times 2x plus 3. We've got this now factored because we've got 2 things multiplied. If we check it again, you'd take, I'll write it on bottom because I don't have enough room on top, 9x squared times 2x, we would get 18x cubed, and then 9x squared times 3, and you'd get 27 plus 27 x squared, and that's what we originally started with, so it does check out. Let's look at C. There's 3 terms. The process is still the same, you just got to do it one more time, and you got to look at all 3 numbers to find your greatest common factor. So, our greatest common factor. We've got 16, 12, and 4. Again, we don't really have to worry about the negative. We will when we start factoring out. But to find the greatest common factor, we're just looking at the numbers without the negative in front of the 12. So, let's see, 4 goes into 12, 4 goes into 4, 4 goes into 16. So we definitely got a 4. That's the biggest number that goes into them. And again, they all have an x, just different powers. X cubed is the smallest power, so that is what we use for our greatest common factors, 4x cubed. So that's what we're going to put out front. And then we're going to divide each of these numbers by 4x cubed. You don't have to write this down every time. You don't have to write down under each number dividing by 4x cubed. I did that in the first 2 examples just to show you what's going on. You can do that mentally in your head if after a while you get used to it. And so if I take 16x to the 5th divided by 4x cubed, 16 divided by 4 is 4. And then I've got x to the 5th divided by x cubed. They cancel out 3 of the 5 in the x to the 5th, so that's x squared that's left. And then I have, now we have to treat this minus as a minus. I have minus 12, x to the 4th, and I'm dividing by 4x cubed. If I take negative 12 and I divide by 4, I get a negative 3. So that makes it minus, inside the parentheses, minus 3 x to the 4th divided by x to the 3rd, is x to the 1st is just x. And then I've got 4x cubed divided by 4x cubed in the last one. 2 ways to think about this. 4 divided by 4 is 1. X cubed divided by x cubed is also 1. 1 times 1 is 1. So that's plus 1. The other way to think about it is if you've got a number divided by the same number, you always get 1. Like 4 divided by 4 is just 1. And so 4x cubed is just a number, and so is we're dividing by 4x cubed, which is the same number, it's still just 1. If we did the check here, you should have, we distribute 4x cubed times 4x squared, that is 16x to the 5th. 4 times 4 is 16. X cubed times x squared, you add the exponents. 3 plus 2 is 5. 4x cubed times a negative 3x, we got 4 times negative 3, that's negative 12. X cubed times x, we add the exponent. The x by itself has a 1. So there's a 1 exponent right there. So x cubed times x to the 1st is x to the 4th. And 1 times anything is itself. So 4x cubed times 1 is just 4x cubed. And my cubed is a little sloppy there. So it comes out 16x to the 5th minus 12x to the 4th plus 4x cubed. That's where we originally started with the problem. You're going to try the checkpoint 2. Checkpoint 2. Pause here. Work at them. When you unpause, I'll put the answers down right here. All right, so checkpoint 2 for A, we had to factor 6x squared plus 16. You get 6x cubed plus 3. That's our answer. For B, you had to factor 15x to the 5th plus 12x to the 4th minus 27x cubed. And we get 3x cubed times 5x to the 4th plus 4x minus 9. Again, the checkpoints. If you're not getting the checkpoints, you should ask me about them in class. We can go through the checkpoints in class and I can help you, because you should be getting these checkpoints. That way you'll know that you're doing things right. All right, let's move up here. The last thing, factor by grouping. We're still going to use the greatest common factor to do this. The only difference is we have 4 terms now. And when you have 4 terms, you group them. And you group them first 2 terms and last 2 terms. So if I group them like this, first 2 terms and last 2 terms, I then look at each group and I factor out a greatest common factor from each group separately. So the greatest common factor in the first group is just x squared. So if I factor that out, that leaves me with x cubed divided by x squared to be an x, cancel out 2 of the 3, plus 4, and the x squareds will cancel out. That's the first group. The second group, we're going to factor the greatest common factor out of that group. You've got no x on the 12, and so you're going to have to just use the coefficients, the numbers. 3 and 12, the biggest common factor out of those is 3. And so we are left with x plus 4. Now, the next thing, what's in the parentheses? What's inside the parentheses has to match at this point. So this thing and this thing, they need to match. And if they do, you did this right. And so what we have, if we're looking at this, we really have 2 terms. We have this first term, x squared plus 4, or x squared times x plus 4, plus, there's the plus, and we have this term, 3 times x plus 4. It's really just 2 terms. It's like x plus y. It's just longer. And within those 2 terms, they share. They share something in common. They share what's in the parentheses. That's why they have to match. And really what we're doing here is we're going to factor out that x plus 4 now. And so each parenthesis has an x plus 4, so we can say, all right, well, there's an x plus 4 in each one. And then we times that by, because remember factoring, we're still factoring, it's just things multiplied together. So we're timesing that expression x plus 4 that they have in common times what's left after we take the x plus 4s away. So what's left is x squared and plus 3. So that goes in to the second parenthesis. And if we wanted to check this, we would have to FOIL. FOIL is just distributing twice. You would take x times x squared. you'd get x cubed. You'd take x times 3, distribute it, so plus 3x. And then you'd take 4 times x squared to be plus 4x squared. And then we'd take 4 times 3 and get 12. And you can see we've got almost the same answer. The 3x and the 4x squared are mixed up. That's because these things are usually written by powers in descending order. So the biggest one first, the smallest one, then the next smallest one, and then the one without a power. And if we did that, we would get our x cubed plus 4x squared plus 3x plus 12. We can do that because commutative property says we can swap two things that are added together and it still is equal. Let's do B. We have to group these two things right here. And when you have a minus in the middle, you don't have to do this. I like to group the minus with it. What that tells you, if there's a minus there, it tells you you have to factor out a negative. I'll have to split that word up. A negative. So when we get to factoring, taking the greatest common factor out of the second set of parentheses, we're going to factor out a negative there. So let's look at what can we factor out of the first set. They both have an x. They both don't have a y, and they both don't have numbers. Well, the first one has a number. It's just a 1 in front, but we don't worry about 1s in front of coefficients when factoring. So they just share an x. That's what the greatest common factor is. And we're left with y plus 5. And now we're looking at the second bit, negative 4y minus 20. Anytime you have a negative that's in the middle, I just said, I wrote it down, you got to factor out a negative. If we factor out the negative, we put the negative with whatever number's there, that whatever number is the greatest common factor between 4 and 20, which is going to be 4. So we're going to factor out a negative 4. And that gives us y, because we're taking negative 4 divided by negative 4 and getting a positive 1. Basically it cancels out and we got just the variable left, y. And now we got to take negative 20 and divide by negative 4. And that gives us positive, because a negative divided by negative is a positive, positive 5. We see that we got our y plus 5's matching. So we got a y plus 5 times x minus 4. Now, I'm not going to check this one because I want to tell you about something else. Some of you will ask, or ask to yourself, can I write them in the other order? Yes, we can. There's a commutative property of multiplication. You can write them x minus 4 times y plus 5, and it is perfectly okay. They are equal to each other, so I'll put a little or here. You can do either or, one or the other. You don't have to write both all the time, just one or the other. Pause here. Work on your checkpoints. When you unpause, I will give you the answers. Checkpoint 3 part A is the answer came out to x plus 5 times x squared plus 2, and if you have it in the other order, x squared plus 2 times x plus 5, it's okay. B is y plus 3 times x minus 5. Same thing. If you have it in the other order, it's okay. Now, the assignment down here is wrong. I will give you the assignment. Don't use that assignment. I'll give you an assignment in class tomorrow. So that is all for factoring out the greatest common factor and factor by grouping. I will see you in class.